We are going to do a lot of factoring related to the factoring of trinomials during this course. The vast majority of the trinomials that we will be looking to factor will take the form ax squared plus bx plus c. In those cases, a, b, and c are all constants. A is, of course, not allowed to be 0 because if it was, then there would be no quadratic term. But here we have quadratic trinomials that we are looking to factor. Unfortunately for us, most of the time that we're going to be looking to factor polynomials that look like that, they are not going to start by looking like that. We will often have to engage in some kind of simplification or other factoring technique that will get us to that point. Now, once we're at that point, you can use the AC method, which is what we'll walk through in this example, to factor these polynomials. That factoring can also take place with trial and error, guessing and checking, and I'll show you what that looks like at the end as well. So to get started, we have a polynomial 3x to the 6th minus 11x to the 5th minus 20x to the 4th. Clearly not a second degree trinomial. It's a trinomial, just not of the second degree. In this case, we're obligated first, as always, to look for a greatest common factor. That should always be our first stop, regardless of whether or not the polynomial is a trinomial, a binomial, or any other type. We should always be looking for that greatest common factor. In this case, we can clearly see that we have a greatest common factor of x to the 4th. Every one of these terms has at least x to the 4th in it. Factoring out that x to the 4th leaves us with the following polynomial. Now, the AC method uses the numbers that are already in the polynomial to try to get a simpler version and allow us to factor. So the first step of the AC method is to multiply the number we identify as A and the number we identify as C. So here's A and here's C. Multiplying the two of those together, we get negative 60. We're going to need that negative 60 line to help us create the next line. And the next line, we're going to look at that negative 60 and this negative 11. We're going to say we need two numbers that multiply together to make negative 60 and add together to make negative 11. Now, the classics for negative 60 are 10 and 6, 15 and 4, 20 and 3, and 60 and 1. Now, manipulating all of those different combinations, you might be able to discover, and if you want to pause the video and try it on your own, I would, of course, recommend you do that. But if we're looking for a product of negative 60 and a sum of negative 11, we know one of the numbers has to be positive and one of the numbers has to be negative, and those two numbers are negative 15 and 4. Those two numbers are how we are going to split this middle term right here. So we'll say x to the 4th, 3x squared, and we're going to write negative 11x, but we're instead going to write it as negative 15x plus 4x. And then we'll finish off with our negative 20. Now, the reason that we want to do this at this point should be pretty obvious. We've gone from a 3-term polynomial to factor to a 4-term polynomial to factor. Once we're in the 4-term version, we can bring in factoring by grouping. We couldn't do it before, but we can do it now. So looking at this polynomial that's inside of here, we're going to break it into two groups, just like we did with factoring by grouping. And we're going to factor each group separately. The first group, we're looking for a greatest common factor, and I see 3x as the greatest common factor. That leaves behind an x and a minus 5 taken from those two terms. Now again, if we want factoring by grouping to work, we better hope that the second parentheses is going to have x minus 5 in it. And in order for that to happen, we have to take 4 as our greatest common factor of the back. Simplifying this entire expression into something a little bit neater, we're going to say that we have the largest common factor of x to the 4th. I shouldn't say largest, but the first common factor of x to the 4th. We have the common binomial x minus 5, and we have the leftover greatest common factors from the grouping 3x plus 4. Looking at each one of those terms, We see that the x to the fourth is a monomial. That's done. There's nothing else we can do there. X minus 5 is finished, and 3x plus 4 is finished. Now, factoring by grouping is a really nice technique to use here. But if you wanted to engage in some trial and error, you could imagine what that would look like. Ignoring for a second, just for a second, this x to the fourth. We're going to pretend that he's not there for right now. And we're going to look at this compared to that. Now you can see how all of the individual pieces fell into place. You can see that the -5 times the 4 would make the 20. You can see that the x and the 3x would make the 3x squared. You can see that x times 4 and -5 times 3 would make these two terms, which combine to make the -11x. Trial and error asks you to come up with those numbers on your own. That is not an ideal process because there are many combinations, in some cases way too many to check. You could imagine that if I just handed you the polynomial 3x squared minus 11x minus 20 and asked you to factor this, and so you would say, okay, I'm going to have these two parentheses, I'm going to have 3x and I'm going to have x, and then I need numbers that multiply together to make 20. So I don't know, 10 and 2. And then you're testing those two multiplications and seeing if you get 11. Well, I don't put any signs in, but I know it has to be negative, so I'll throw a negative there and a plus there. That didn't work. Maybe I flip them. Maybe this becomes the positive and this becomes the negative, and that still doesn't work. And so then you try a different multiplication to 20. So maybe you try a 5 here and a 4 there, and you put the 5 times the x and then the -4 times the 3x. Would you get to the right combination eventually? Sure you would. But trial and error there's no guarantee that you're going to find the answer in a very, very fast or efficient way. The AC method may take a little bit longer in certain cases. This strategy for breaking that middle term into two different terms, it may take a little bit longer, but there's also a almost guarantee that it's going to work. I can't say guaranteed because there are some trinomials that are not factorable. You will run into ones that do not have factors. But that doesn't mean that the process is bad. It just means that the process won't work. Here, you could be trying forever and think that you still don't have the right combination. So you want to be careful with trial and error, just guessing factors and trying to get them to match when you have a method that you know is going to work.